Hey guys, tonight we are going to be graphing those last four of the trig functions. We've only been dealing with sine and cosine this past week, so now we're going to go ahead and add in tangent, and then we're going to add in the reciprocal values. So two things you're going to be asking yourself is, how do I graph reciprocal trig functions? And then what is the period of a tangent graph? It's a little different than our other ones. Before we start, I want to make sure we remember a couple of key facts, mostly our reciprocal trig identities. So if you remember, we have three reciprocals. So if I take the secant of theta, I'm really just taking 1 over cosine theta. So I'm flip-flopping whatever cosine was. Okay, cosecant goes with sine of theta, and you're just flip-flopping them. And finally, cotangent goes with tangent. So those are our reciprocal identities, and they're going to be very helpful with us graphing these reciprocal trig functions. The other thing I wanted to remind us of are our quadrant border angles, the quadrantal angles, and because remember, these are our critical points that we graph when I'm making my beautiful trig graphs. And so when I'm looking here, O, I owe you, oh, I don't owe you, and we can also use our radian measurements here. And then to realize that wherever my graph is 0, if I take a reciprocal of it, if I flip-flop it, I'm going to be undefined. So if you can remember these values, we can graph these pretty easily. Okay, so let us move on and start graphing our first reciprocal identity. Okay, so right here, we have this is secant. And we just talked about secant is going to go with cosine. So it's 1 over the cosine of x. So if I know those critical values for cosine, I can go ahead and graph secant. So there's two ways you can do this. The first way is you can go ahead and use your XY chart, and you can graph those points when they come up. So I'm going to go ahead and do this in degrees. So we would know that 0, 90, 180, 270, and then 360 will make a full period in a cosine graph. And so this is the same idea for secant. So if I remember, with cosine, the cosine of 0 is 1, so the cosine of secant is also going to be 1. The cosine of 90 is 0, so that means for secant it's going to be undefined. The cosine of 180 is -1, so if I flip-flop it, it's still -1. And then 270, again, it's going to be 0 for cosine, so it'll be undefined, because it can't divide by 0. 360 starts that process over again, so it's 1. So what's going to happen where you have a u in here is you are going to have those asymptotes that you talked about with rational functions, because when I look here, I have a fraction. It's a rational function. So what I'm going to go ahead and do here is I'm going to graph a couple of periods of cosine and then show you how you can get the secant graph out of there. Okay, so again, my purple graph is going to be cosine. So when I look here, we know that I didn't have any phase shifts, so my amplitude is going to be 1 and -1, still have my c as 0. And when I think about my period, remember your period is 2 pi, and so all of your things will start repeating after 2 pi, or excuse me, we're doing degrees, so 360. So I'm going to go ahead and plot those points. And then I'm going to go ahead and do some negative ones too, just for posterity's sake. So if I was starting with cosine, remember, you start up here at a high point, go down to your middle, go down to your low, middle, high, and if I wanted to continue on this side, middle, low. And so this right here, ooh, well, I tried. That would be the graph of the cosine. Okay, I guess I could go down one more. It's 540. But remember, this is taking the reciprocal of it. So anywhere you see on your graph a 0 for cosine, that's where an asymptote's going to be. So I'm going to, wherever I have a 0, I'm going to draw in some vertical asymptotes. I forgot the arrow up here. So anywhere you have a 0 on your graph, that's now an asymptote. So when I look here, if I was to graph this, wherever these two values are the same, right? So at 0, 1, it's still going to be 0, 1. But instead of going down like a cosine graph is going to do, it's actually going to make these funny little parabolas up at the top. So same deal down here. It's still going to be the value of negative 1 at 180, but it's going to make these little parabolas down here at the bottom. And so basically, wherever the top of your graph is, that's going to be the bottom of a parabola on a secant graph. So high cosine points are the bottom of parabolas, and vice versa. Low cosine points are going to be the top of those parabolas. But those mid cosine points, where you were 0, those are now asymptotes. Okay, so again, that purple graph is just kind of a guide for me. I could go through and erase that, and that would be the correct graph. So my blue is my secant graph. So when I'm looking at this, I can always use all the same rules that I was using for the cosine graphs as far as vertical shifts and amplitude changes and phase shifts and period changes. But now I'm going to go back through and say, well, any place I'm 0, I actually have an asymptote, and then draw those parabolas at my high and low points. So again, everything still kind of works the same. It's just you're going to draw a guide for yourself and then put in your new parabolas. Okay, so cosecant kind of works the same way. And cosecant here, I'll write it out for posterity's sake, and I'll go ahead and I'll graph this one in radians just to check it out. So it's the same idea. You don't have to draw the table of values if you knew how to graph your sine graph, because remember, cosecant is the reciprocal of sine. So I'm going to go ahead and try to make a nice graph. Kind of doubt it's going to happen. And so remember, when you have sine, your period is 2 pi, which makes your critical points every pi over 2. So we have 0, we have pi over 2. That's 90, then we have 180, pi, 3 pi over 2 for 270, 2 pi for 360, and I'm going to go ahead and graph a couple in the negative direction. Negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. So I'm going to go ahead and graph this sine graph first. Again, there aren't any amplitude changes, and my C is still 0, so I can still start at the x-axis. And remember, sine starts at a low point, or a middle point, I guess. So it starts at a middle point, goes up, middle, low, middle. And if I went backwards, this would be down here at a low, a middle, a high, a middle. So I've graphed 2 periods, well, 2 cycles of my sine graph. So again, when I am looking at this guy, I'm going to go through, and wherever I have a 0, that's going to make an asymptote for me. So here at negative 2 pi, here at pi. Because remember, if I take 1 over 0, that's no bueno. There's going to be an asymptote here on the y-axis, asymptote here, and finally at 2 pi. So same deal here. Wherever you have a high point on your sine graph, that's going to be a bottom of a parabola. Wherever you have a low point, that'll be the top of a parabola. And you just go through, make sure you don't touch your asymptotes. And this would be the graph of cosecant. So remember, the blue is a guide. And you are welcome to draw it every time, and if you want to erase it or you just want to make it clear to me that the pink is actually the secant. Or sorry, cosecant. Struggling, can't read today. Okay, but the blue is not the answer, so you can always go through and erase it or just leave it like that and make sure you make it clear that it's that. So again, if you can graph a sine and a cosine graph, all you have to do is then draw in your asymptotes and then make parabolas out of that original graph. Okay, same period, same all that stuff. We're just changing flip-flop and stuff. Okay, so the last one that we need to look at is tangent and cotangent. So we haven't seen tangent before, and I'm going to go ahead and draw that XY chart for myself since we haven't seen it, and I'll go ahead and do it in degrees again. So 0, remember if I have the tangent of 0, that's just 0. The other ones that we knew were 90, and I could do negatives if I wanted. At 90, remember, that's going to get me an undefined value. So if that's undefined, there's going to be asymptotes in here. If you have a U, you're going to have asymptotes in there. The other one that we know that's kind of a nice value, because I don't want to deal with radicals and whatnot, is we know that the tangent of 45 is 1, or the tangent of pi over 4 is 1. Because I look at those opposite over adjacent, I get 1 over 1. Okay, so I have 0, 45, 90. I'm going to go ahead and graph a couple in the negative direction, because I'll just start repeating after that. Negative 45, remember if I flip-flop under the x-axis, that'll get me a negative 1. And then negative 90 is going to get me another undefined. So I'm going to go ahead and plot those points. Oh my gosh, that was like the least straight line I've ever drawn. Okay. And then I'm going to graph those points. And again, I'm doing this in degrees. So we have 0, 45, 90. Then we have negative 45, and we have 90. So wherever you have U's, that means that you're going to have an asymptote. So you're going to draw in that asymptote. And we know at 0, my tangent was 0. At 45, it was up here at 1. And at negative 45, it was down here at negative 1. So remember, I'm going to kind of draw it the same way, and you can check this in your calculator if you don't believe me. But it's going to be this weird, well, that's totally a line. I'm trying so hard. Weird swirly looking thing. Okay? And so when I look at this, in order to get from here to here, that's a complete cycle. So if I drew another one of these and I just kept adding 45, so 135, 180, 225, 270, we know that the tangent of 180 is 0 again. The tangent of 135 is going to be negative 1. The tangent of 225 is going to be positive 1. And then at 270, it's undefined again. So if I look at this, and again, I'm terrible at drawing tangent graphs, is what we've learned. If I look at this graph, my period is only 180 degrees. I went from 90 to 90, or went from 90 to 270. So my period is actually half of what my other ones were. So in order to make that full cycle, in order to get from asymptote to asymptote, you only have 180 degrees to go. So when I am trying to graph these guys, your period is 180. Tangent is always going to start, so if as a phase change, it always starts with the center point. So it starts in that middle. When you look here, this is really weird, but this is from this point down to your bottom point. That's considered your amplitude. So of a regular graph, that would have been from the middle point up to the high point, but my high point goes on forever and ever and ever. So if you think if you have any vertical stretches, you're just going to consider that and label that point, whatever, 12 or whatever your stretch is. So tangent, you start with your center. Your amplitude is always going to be from a 0 point, a middle point, up to a high point. And then your critical points are always going to have asymptotes involved in them as well. So you have asymptotes, then you have a low, a mid, a high, and then an asymptote. Okay, so one cycle is 180 degrees, or just 1 pi. So let's quickly talk about cotangent, because it's basically the same thing. We're just going to flip-flop it. And I'll graph this one in radians. So again, you can draw out your XY chart. Ooh. If you think about what all your angles are. So again, I'm doing this in radians. Remember, for tangent, pi over 4 or 45 degrees was another nice point for me, instead of just doing those all the quadrant border angles, because that's only one. So I'm going to go ahead and use pi over 4, and then I'm going to use 90 or pi over 2. I'm going to go ahead and do some negatives in here. Negative pi over 4, negative pi over 2, and we'll figure out some more in a little bit. So remember, wherever cotangent is, because right here, this is the opposite of the reciprocal of tangent. So if tangent was 0, then I'm undefined, and I now have an asymptote there. At pi over 4, cotangent is still 1. At pi over 2, that's where tangent was undefined before. But I can do that. If I flip-flop an undefined to 1 over 0, that's just 0 over 1. And that will get me a real value. Okay, now at negative pi over 4, tangent turns negative, so we'll have a negative 1. And at negative pi over 2, again, that would be 0. So let's go ahead and graph this, and we may need some more points in a second. Seriously, what is wrong with me? Okay, and so when I look here, I'm going to graph pi over 4, pi over 2, negative pi over 4, negative pi over 2. So remember, I'm looking for asymptotes here. So I'm going to go ahead, draw in one of them. We have one right here at 0. And then I have a pi over 4 is 1. Now I guess I should draw in my amplitude. No phase shifts here, so we're good. Pi over 2, it's 0. I'm going to go ahead and put in a couple more points in here. So if I looked at pi, go 3 pi over 4 would be negative 1. And then go out to pi. Remember, at pi, it'll be undefined again. And then I have a low point. So my graph of cotangent, I did a little better that time, would look like this. And again, you can continue your graph out this way, because at negative pi over 2, we're at 0. Then we would be at a low point, a high point, and then there'd be another asymptote over there. So that's what your graph of cotangent looks like. So basically, wherever tangent had an asymptote, now you have a 0 point, and wherever tangent had a 0 point, you have an asymptote. Okay, and then again, this one goes from high to mid to low, but cotangent starts with that asymptote if there's a phase change. So let's quickly summarize all those things that we just saw in that general formula for tangent and cotangent. So this is that general formula we used to see with sine and cosine in it. Now we're going to talk about how it's slightly different for tangent. So remember, C is going to be a vertical shift, and that's basically just the height of your center points. So where are those middle points for you if they're not on the x-axis? Okay, A is that amplitude value. Remember, that's just kind of how big it's been stretched. It's not really an amplitude, but we'll fudge it a little bit and call it amplitude. B, how you find your period, is going to be, instead of being 360 for this one, it's going to be 180 divided by B, or just regular pi divided by B to give you your period. Okay, and to find those critical points, you're still going to take your period divided by 4, but this includes asymptotes. So it's not just high, low points or middle points. It's also asymptotes that are in your critical points. Okay, and then the last thing is your D value, that phase change. And so when that, remember, that's where you start. So the first X value. And for tangent, you're always going to start with a center point. So when you're looking at that, you're going to start here at a center point, but cotangent, you're going to start at an asymptote. So you're going to start with one of the dotted lines, and it'll tell you exactly where you start. Okay, and so that follows the same rules as the other ones, and we're going to go ahead and practice how you graph these types of functions tomorrow in class. So I hope you have an excellent evening, and I will see you tomorrow.